Hey everybody, in this video we are graphing trig functions. We're going to determine the amplitude, period, and phase shift for y equals 5/2 sine of the quantity 2x plus pi over 2, and then we're going to graph one period of the function. I'm going to be a little less detailed. In the description box there will be links to the introduction of how to graph sine, and if you go to that video, in that description box is a playlist of a bunch of examples how to graph sine, cosine, etc. So let's go. Alright, so my amplitude in this situation is 5/2 as a fraction, which is 2.5 as a decimal, and it's always positive, please. Here, I can factor out that 2, which I would probably like to do, and that is not going to leave me with pi, but it leaves me with pi over 4, because when you factor out the 2, you undistribute the 2, so that means you have to divide by 2 or multiply by a half to take it out. To check if you're right, you can redistribute the 2. Also, you can set your original parenthesis equal to 0 if you wanted to figure out the phase shift, and just know it'll be the opposite sign, just like we always talk about with the backward house, yada yada. I'm just going to write that. So the period is affected by the b value. So the period is 2 pi over b, which is 2 pi over 2, so the period is equal to pi. The phase shift, like I just mentioned, you could set that entire inside of the parentheses equal to 0, but it is going to be either negative pi over 4, or you can even put left pi over 4. And something else that we often end up finding is a quarter period, which is the period divided by 4, so pi over 4. So phase shift negative pi over 4 is my first tick mark, negative pi over 4. We have 5 tick marks all together when we're graphing sine, cosine, secant, or cosecant, one entire period. If I add q each time, I will get the other 4 tick marks. So that will be 0, pi over 4, 2 pi over 4, which yes is pi over 2, and 3 pi over 4. Sine, this is a positive sine wave, so if you forget what sine looks like, go around the unit circle. Sine equals 0, then 1, then 0, then negative 1, then 0. That in a graph is 0, and then 1, 0, and then negative 1, back to 0. Concave down looks like a frown, concave up looks like a cup. This pattern repeats forever and ever. The domain is negative infinity to infinity. It does continue this exact same picture forever. If it were negative out front, we would flip it over, okay? Now, what else do we got? My amplitude of 2.5 is telling me that this distance and this distance is 2.5. 2.5 going up and 2.5 going down. The 0 over here, while we're at it, so that's all the stuff there. The 0 right there is your sinusoidal axis, or your midline, depending how you refer to it. That's right over there. Since the amplitude is 5/2 or 2.5, then I can label my upper and lower, my max and min, as either 5/2 or 2.5 from 0, and then negative 5/2 or negative 2.5 below 0, right? Anything else? No, I don't think so. My range would be negative 2.5 to 2.5 with brackets, and again, my domain is negative infinity to infinity. Tan, cotan, secant, cosecant do not have a domain of all real numbers, but sine and cosine do. I think that's more than everything. I went into a little bit more detail in example number 15. That's it for now. Check the description box for links and all that good stuff to help you out. If you need something more specific, I have it all tucked away. Maybe you can't find it on my YouTube channel. Maybe you can. Maybe you are a professional navigator there. Great. But if you need help, let me know in a comment. If you're loving it and you know it, thumbs it up. If not, thumbs down. Questions, comments, concerns, feedback, requests, whatever, put it in the description at the underneath the video. Check the playlist, check the description. That's it for now. Adios.